this video, we're going to go over Laplace transform, specifically the time delay theorem. So, if the inverse Laplace transform of a function of s is a function of t, then the inverse Laplace transform when you have e to the negative sa with the function involves the Heaviside function. So this is the Heaviside function. So we're going to do some examples now. So we have the inverse Laplace of e to the negative 3s over s squared plus 1. So, as mentioned before, we want e to the negative sa by separated, so we can identify the inverse of the actual function to have the appropriate a's in. So we have 3 to the power of negative 3s e to the power of negative 3s over s squared plus 1. So that can be separated into 1 over s squared plus 1 multiplied by e to the power of negative 3s. So we want to find the inverse of 1 over s squared plus 1. So if we look on our table, we're looking for 1 over s squared plus 1. So we can see that that could fit into sine, where we have 1 over s squared plus 1, so it would be sine t. So function of t is sine t. So with the Heaviside function, we need h t minus a and f t minus a, where the a comes from this bit. So the inverse is h t minus, we have 3, and then the function, which is sine t, so sine t minus, and the value is 3. So that's it. If we do one more example, we have the inverse Laplace of e to the power of negative 2s multiplied by s minus 3 over s squared minus 6s plus 13. So we can separate it. We're going to separate and pull this off. So we have s minus 3 over s squared minus 6s plus 13. We're going to multiply that by minus 2s. So we've pulled it off to separate them, and we're going to identify the inverse of this. So we know, looking from the power on here, that a equals 2. So we know it's going to look something like this. And the function, when we identify what it is, will look something like this. So we want to find the inverse of this function here. So if we look at our table, so we have a few values and we're looking for this. So we're looking at, it could be cos. If we completed the square, we would have, because we can see that 3 is half, 6 is half of, half of 6 is 3. So if we had s minus 3 squared, and then we would have positive 9 plus 4. So completing the square, we could see the link of the two of the same numbers. So we're thinking it could be cos. So we have equals. So if we have h t minus 2, and then we have cos with the e to the power of at attached to it. So it would be e to the 3t, because we have 3's here, like on here. And then we would have cosine wt, so w in this case would be 2, so 2t. But because we're substituting for t minus 2, so it would be h t minus 2 to the 3t cosine 2t minus 2. That's it. So that's how you would use the Heaviside function in the time delay theorem for Laplace transforms.